Hello and welcome back. I'm Mr. Ryder, and this is our third and final installment in the geometry quote speed math. So today's lesson is going to involve lines, parallel lines, and a line that's called a traversal. And what we have here is we have an understanding of the relationship with angles that are being created, and more specifically their measurements. So let's get right into this, and we'll start off with two parallel lines. And what I've asked the kids to do is they can label these lines, and we've discussed this in our second lesson. We'll call this line AB and line CD. There's a third line that crosses these two, and we can label this one E and F. So we'll call this line E and F. And what we have here now are two parallel lines crossed over by a transversal, and we form angles. And here's a pair of angles, and then here's a pair of angles. When angles are across from each other, we call these vertical. These are vertical angles. And vertical angles are always equal to each other. So no matter what type of diagram or picture you're looking at involving lines, all angles that are vertical or across from each other will always be equal. And the technical term for that would be congruent, although we don't really use that too much at this level. If in fact this angle is equal to this angle, then what we can say about this angle here is that this angle and this angle are also equal to each other. And they are also considered to be vertical angles. And I can say the same for down here. This angle is a vertical angle to this one. Now where the kids get confused is a lot of times what I'll do, and I'll just erase some of these little arches here, and instead of putting these arcs in here indicating that we have an angle, I usually label them with a number or a letter. So we'll go with the numbers right now, 1, 2, 3, 4, 5, 6, 7, 8. And I'll ask them to tell me what are the vertical angles. And the way they should respond is angle 1 and angle 4. This is a pair of vertical angles. And angles 3 and angle 2. And then the same can be said for here, angle 7 and angle 6. So this explains what vertical angles are. The next part of this lesson, and then we'll stop on this part A of lesson 3, are what we call alternate interior angles. And its sister would be alternate exterior angles. And for the sake of our lessons in class, I always break down what the meaning of each of these words are. Alternate meaning opposite each other, and interior being on the inside, and exterior being on the outside. So, if we're looking at this particular diagram here, and I'm asking kids to look at the angles on the interior, on the inside, I expect them to recognize that these four angles are what we would consider to be interior angles. They're inside the lines. And the obverse of that would be exterior, would be angles on the outside of the two lines. So the only other thing that they need to recognize at this point, if they get the inside and the outside, is that what angles are opposite each other. And in this particular case, for alternate interior, angles 3 and 6 are opposite or alternate interior. And angle 4 and 5 are alternate interior. Then we move to the exterior. If you look at angle number 7, and the opposite of 7 would be 2. And the opposite of 8 here would be 1. These are opposite or alternate interior and exterior angles. And the way they would write this is, they would take alternate interior angles and they should write it like this. Angle 3 and angle 6. Angle 4 and angle 5. And for alternate exterior, it's going to be angles 1 and angle 8, and angle 2, and angle 7. So what we've covered here today are vertical angles, alternate interior angles, and alternate exterior angles. In part B of this lesson, we'll talk about adjacent angles, we'll talk about supplementary angles and complementary angles. So thank you for joining me today, and I look forward to seeing you again in part B.